Please get out your notes sheet for 6.5 linear inequalities.
So a quick review of linear and then inequality that we're going to be putting together. We're going to go ahead and put a best definition for linear and then inequality. So if you want to think of something that you have right now in mind, and then we'll take a look what these mean. So a good definition of linear is just a straight line, and then for a definition for an inequality is to be not equal, and that means that there contains multiple answers for inequalities. Just like when we solved regular ones on a number line, the same is going to be true for when we do linear inequalities. So a linear inequality represents a graph of a line that can be written in slope-intercept form, which is y equals mx plus b, but will contain an inequality sign in the place of the equal sign, since we're dealing with inequalities instead of linear equations with an equal sign. And because these graphs contain inequality symbols, there are more solutions to the graph than just the line itself, depending on the shading, just like with regular inequalities. So with linear inequalities, the direction of the sign, meaning the inequality sign, and the kind of sign will determine the kind of line you draw and the direction that you will shade. So these are your steps for graphing linear inequalities. Let's take a look at those. Please copy down the things you need to and pay attention to these steps. They're really, really important. All right, so step 1 is to write the inequality in slope-intercept form, which means solve for y. And then what you want to think about, because this is going to have an inequality symbol instead of an equal sign, is that you don't forget the special rule for inequalities. When you have to multiply or divide by a negative, you're going to end up flipping that inequality sign, just like with regular inequalities. So once we solve for y and have it in our slope-intercept form, we're going to go ahead and put our first point at the y-intercept. This is just like plane slope. And the same step as well. So from the y-intercept, use your slope to plot more points, and then here's where it's going to be a little bit different. So before you connect your dots like you're used to and make your line, you need to determine what kind of line you're going to be drawing based on the inequality symbol, and then draw your line. So here's what we know. We have for less than or greater than, we're trying to show that our inequality represents things not including that line, because we don't have the or equal to. So for this kind of line, what we would do is a dotted or dashed line instead of connecting the dots. You want to kind of make it a dashed line. But then if we have less than or equal to, or greater than or equal to, then we're saying we are including that straight line itself and then anything else. So that's where you're going to make a solid line. And then once you either make your dotted or solid line, you need to determine where you're going to shade. So just like a plain number line, you would think open or closed circle, and then shade left or right. This is the same concept, it's just slanted lines. So if we have something that's less than or equal to on a plain number line, we would shade to the left. On a linear line, which is slanted, you're going to shade below that line, which could be sometimes down towards the left or down towards the right. It depends on the line and what the slope was. And then for greater than or equal to, you're going to shade above the line that you had. Last thing is, wherever you shade, just like with a number line, with a plain number line, you can always pick something you shaded and check it. Here it's going to be, you can pick an ordered pair where you shaded and plug it in for x and y, since it's an ordered pair, and then make sure it makes a true statement back with your original inequality. So we're going to take a look at how these work, but it's really just slope-intercept form again, but adding some dotted or dashed and some shading. So this one's not in your notes, so we're just going to take a look at this so you guys can understand what we're looking at. So right here, you see that it's a straight line in red, so this is just like slope-intercept form, but then you see the shading going on. So we've got to figure out, what inequality goes with this, since we're not just saying that the red line is our answer, but anything that's shaded right now above that red line is also an inequality. So we would still focus on slope-intercept form, which would be pick some good points and calculate your slope. So I see my slope is up 1 and then backwards 1. So I know my slope is -1. My y-intercept is right here at +1. So nothing changes from the fact that I still know this equation in slope-intercept form should be -1x plus 1. Now, the only thing that we've got to think of differently now is that inequality sign. So if I go over and look at my 4 answer choices now, if I kind of just match up with my slope and y-intercept, it's not going to be letters A or B, because they have a +1 slope, we need a negative. So now I've got to determine which one of these inequalities, C or D, is true. So what I have is I have this solid line, which means my answer is this straight line that you have, but then everything else above it. So because this is a solid line, we need that or equal to, which makes this letter D. Letter C would look just like this, except that red line would be dashed instead of solid. So here's another look just to get you guys kind of in the mode of understanding these. This one again is not in your notes, the next ones will be. So if we had to write this inequality in slope-intercept form, we would do the same concept as slope-intercept form where we would need the rise and the run. So if I pick some points and calculate my rise and my run, it looks like I'm going up 3 and forward 1. So I know my slope is 3 over 1. B, my y-intercept here is at -1. So again, I can at least know in slope-intercept form this is what I would have, but I've got to adjust that inequality symbol to match what I see here. So I can keep y, 3x, and -1, but I've got to change that equal sign because now what I'm trying to show is my answers or anything in the shaded region, and then possibly that line. So here we see a dashed line, which means my answers are actually not along that line. Only numbers that are shaded right now towards the bottom right of this line. So because it's not a solid, this would either be greater than or less than, and then depending on the shading is how we know if it's greater than or less than. So if you kind of focus on this line, we are shading, and imagine this shading going on forever. It's going towards the right, but it's also going down, so this would be a less than 3x minus 1. Okay, so here's your first practice, and you're actually just going to graph these right now and practice with your shading and dotted or dashed. So we've got our slope, we've got our y-intercept, so we can at least graph those. So put your first point at -1, go up 4 and forward 5, and then we can go down 4 and backwards 5. Now you're used to just connecting and being done from there, but we're not going to do that. We need to figure out if we're going to do a solid or a dashed line, and that all comes down to this inequality symbol. So we've got only things less than this line should we be shading. So not including the line means we're going to make it this a dashed line to show that our line itself is not a good solution, but then anything less than this line would be a good solution. So then when you go to shade, you want to show less than, so you're either thinking kind of up towards the left or down towards the right, and less than this line would be numbers down towards the right. Now I had said earlier how you can check this, so you can pick anything you shaded, and I'm just going to pick 3, 0 because that's within my shaded, and I'm going to see if that point 3, 0 can go into that original inequality and make a true statement. So if I did 0 for y and 3 for x, I should get that 0 is less than whatever I get on the other side. So 4/5 times 3 is really 12/5. 12/5 minus 1 is like 12/5 minus 5/5, and that's 7/5. And I'm basically saying 0 is smaller than 7/5, and that's definitely a true statement. So you know that you should be shading down towards the right or below this line. If you pick something above the line, it should not work. So another way you could have checked this is actually by using 0, 0. 0, 0 should not work, which is actually a little easier to check. And if you plug in 0, 0, you're going to end up with 0 is less than -1, and we know that's not true. That's why you did not shade towards 0, 0. So one of the other things is you can always use that origin as your check, and if it works, shade towards the origin. If it does not, shade away from it. Okay, so your second one, we've actually got to solve for y. So we're going to have to actually subtract 6 from both sides, and we'll get 4x minus 6. So we still have this slope of 4 over 1, this y-intercept of -6. So you can put your first points at -6, and then use your slope. So rise 4, run 1, until you can't fit anymore. And then before you connect again, you have to focus on that inequality symbol. So I have right now that y is greater than or equal to, which means I'm going to be this line or anything above this line. So you do want to connect with a solid line. And then if you want to show numbers greater than this line, you would either be going to the right and down or to the left and up. And because greater than is going to want to go towards the up direction, then you would shade towards the left. So here I have shaded towards 0, 0. So this is an easy one. If you plug in 0, 0, we should get a true statement. And we end up with 6 is greater than or equal to 0, which is true, which means you should have definitely shaded towards 0, 0. Okay, example 3, why don't you try this one on your own, and then you can press play whenever you need to check it. Don't forget to solve for y first. Okay, so when you solve for y, you should get y is greater than or equal to negative 1x plus 4. So your point should look like what I have here, and then before I connect, I'm looking at that inequality sign. Because I have the or equal to, it's a solid line, just like it would be a solid, solid dot whenever you fill it in on a number line. And then we want to show numbers or solutions greater than this line. So it's either left and down or right and up. And greater than goes towards the up direction, so we would shade towards the right. So here, I'm going to be a little lazy. 0, 0 is not shaded, so this should not work. So I'm going to see if I plug it in that it does not work. And remember, it should not be true, so I'm going to kind of put an X over that inequality symbol. So we would end up with 0 is greater than or equal to 12. Not true, so we know we should not have shaded towards the origin. Okay, and this is the last one, and this is the one where you've got to be a little bit careful when you're solving for y. So we're going to subtract x. We would have negative 2y is greater than negative x plus 4. We're going to divide both sides by negative 2, and we would have negative 1 over negative 2, which is 1/2 x, and 4 divided by negative 2 is negative 2. Now here's where you need to be careful. Because you've divided both sides right now by that negative, that inequality sign needs to flip, just like with regular inequalities. That's true when both sides have to get that division or multiplication of a negative. So now this turns into y is less than 1/2 x minus 2. So we'd put our first point at negative 2. We have a positive 1/2 slope, so you can graph your points. And then we're going to go ahead and connect based off of that inequality symbol. It's just less than, so we want dashed line here, not solid. And then our shading, because we had to flip our sign, less than, this line would be down below the line, which is down towards the kind of the right. And then this is where it is, again, really important to do those checks. So I'm going to use, and be lazy again, and use 0, 0, but it should not work because we did not shade there. So if I plug that in to this original, remember it's not supposed to work. So we get 0 minus 2 times 0, which is 0, and we get 0 is greater than 4. Not true, which is good because I did not shade towards there. Anything that I shaded, if I plug it in and check, should work out, but not things that I did not shade. So hopefully that makes sense. One of the big things people typically miss on these is forgetting to flip their signs when you're dividing by negatives. So please don't forget that. So that is it for these. We will practice a little bit more with this next class. Hopefully it made sense, just a little bit different with your shading and more answers than just one. And I will see you guys soon.